So welcome to our third subtopic, and in this subtopic we are trying to explain metadata, standards, and semantics. So what is metadata? So I would like to use a metaphor of a tin of food. If you wanted to buy a tin of food, if your friend maybe brought you this tin and told you this is the best food I have for you, I don't know whether you would accept it, but most likely if they told you that this is the best tin, you'd say, I think I can pass, or maybe you may take it, but you simply don't eat the food. But why would you do that? It's just because you simply can't trust what is inside there. You don't know what nutritional content is there, you don't know the name of the product, you simply don't know what is contained in that product. So it's not very easy for you to evaluate whether the product is good for you and then whether it's useful for you. So typically what is done, there is a standard for food. So this standard basically specifies how food should be documented, and you can see here is an example. We have basically the nutritional artifacts that are contained here, the expiry date here on the top, and the manufacture date. All that information is there on the top. And then we also can be able to see that this has, for example, 120 calories, the total fat is told to us, the cholesterol, the sodium, the potassium, the total carbohydrates, and so many other information. They also tell us the ingredients. Now, this metadata is organized in a particular way. They use particular tags. For example, they say that if you're going to document a particular food bottle or maybe particular food, you must include the expiry date. That's tag number 1. You must have nutritional artifacts. You must have ingredients. You must have the manufacture date. You must have the name of the company, the name of the food. So all this information is there. So if this metadata about the food is not there, then you cannot be able to evaluate whether the food is okay. Neither is it possible for you to know whether we should take it or whether we shouldn't take it. What is this metadata? So metadata is data about a data set. Metadata is that information, or the word meta means a description of that artifact. So a metadata is basically a description of that data set so that it can be discovered. So if you went to a stand in the supermarket, you can be able to discover this food and know that maybe I'm dealing with sugar here, I'm dealing with salmon, I'm dealing with tuna, or I'm dealing with tilapia here. So you can be able to discover it in the first place. But then also you can be able to evaluate whether it is useful. Now that you know what metadata is, would like you to be able to tell us what metadata elements are possible with geospatial data. What should we have as far as geospatial data is concerned? So this you'll find in your e-learning management system. So what is metadata once again? Metadata is data about data. It tells us, for example, the geographic area that's covered, information rules on the usage of data, the positional accuracy of the data, the map projection, the datum, and then this metadata allows producers to be able to explain their products, and then the users can be able to learn about the products. So it's very, very key for interoperability. So most likely non-standard products simply cannot be understood. So with metadata, it allows us to make sure that our data is understood. So usually the metadata is published in a catalog, and that allows you to be able to discover information, and then later on you can access it and use it for the purpose you are supposed to use it for. So let's get further to understand the existing metadata standards. But before we can understand what these standards are or which ones they are, let's understand what a metadata standard has or what it contains. A metadata standard is simply a common set of terms and definitions known as elements that describe an information resource. So when we have metadata, once again, it's very easy for us to be able to meaningfully compare different data sets. If you don't standardize metadata, then it can be very difficult for you to be able to even compare different data sets. So a metadata standard allows for quick search and retrieval for a particular element or for a particular tag, if you could call it that, using a consistent name for the element and a consistent meaning or level of information, and this basically makes the process much easier for you to be able to discover information and even evaluate it. Standards provide a common set of elements, while they still allow flexibility for additional elements to be added so that you can contextualize that standard to your country or to your organization. And they are developed through a consultative process between experts and must be comprehensive enough that they can provide a sufficient level of detail and clarity for the users. So in our geospatial domain, as we shall discuss over time, if it is advisable, for example, we have a resource title, we have a temporal reference date, when was this data collected, geographic extent this data is collected, what extent does it cover? Does it cover the entire of Kampala or the entire country? The resource language, is it in English, is it in Luganda, is it in French? And then also the resource type category, for example, is it about health or it's about infrastructure or military or agriculture or environment? And then the service type, the responsible party, the abstract, some small text to tell us about the data set and the context it was collected, as well as the resource locator. The geospatial domain, we use the ISO 1915 standard to use for metadata. The design philosophy behind this standard is that we describe data or data sets. If we can be able to describe them, then it becomes very easy for us to be able to access that information. So the schema will be used by geographic information users to add metadata in a consistent and verifiable form to data that's being created, and even evaluate quickly and accurately the data that's being selected from other sources. So software developers will be able to use the schema to provide applications that provide consistent methods for handling metadata. So it has different components, as you can see in this UML diagram. So this metadata standard has an entity set information, which defines the metadata about resource and establishes the hierarchy. We have the identification information. So this is basic information that's needed to uniquely identify a resource. And then we have constraints. So we have legal and security restrictions on the access and the use of data. And then the data quality. This is basically telling us or describing data quality and testing. And then we have lineage information. This tells us about the sources and production processes. So other components include the maintenance information that tells us or describes maintenance and update practices. And then we have the spatial representation that describes the mechanism to represent spatial information. And then we have the reference system that describes the spatial and temporal reference system that's used. And then the content information that describes the content, the coverage, or the feature catalog used to define features. The standard also has the portrayal catalog reference or a citation for portrayal catalog used to display data. It has also the distributor information and methods of access. How should we access the data and how should it be distributed? And then how should we extend the different metadata elements? And then it also defines the application schema that should be used and the extent of the dataset, how to define that extent, and then how to cite the resource and the responsible party information. So why is this concept of metadata important? Like we said previously, we use metadata to be able to discover that data exists, and then we can be able to see whether this data is useful to us, and then we can go on to access it if it's useful to us. So why is it important now more than ever? It's just because these days we have a lot of data sets, geospatial data sets in the country or even around the globe for different domains. Just know that every ministry here produces geographical information data. But then also the private sector, even you're producing data now with your small smartphones or your Twitter or Facebook and so many other social media. So in other words, we have a lot of non-geographers who are using geospatial data knowingly or unknowingly. And typically the producer is not often the user of this geoinformation. And more so, geospatial data is imperfect. It's a model view or your point of view. You, the collector, that's your point of view. That's how you see the reality. That's how you see the world. There are so many assumptions. There are so many limitations, so many approximations and simplifications that you make. And also, this geospatial data is very expensive. You cannot keep on collecting it each and every time. So you'd want that it's collected once and typically updated, just like a principle of the NSTI, and then you can always reuse it. So in other words, we need very good data management. We need to describe this information so it's understandable by these non-geographers, so that we can be able to understand your model point of view. We can be able to use this information. So why should it be standardized in the first place? It should be standardized so that we can provide an understanding of the data around the globe and also across information communities. You want that if someone is in the medical field and you send him data, he should be able to understand it just like the way you understand it. So we've been explaining the ISO 1915 metadata standard, but we also have the ISO 19139 metadata schema implementation. So this basically is required for describing geographic information and services. So it has information about identification, the extent, the quality. It also has information on the spatial and temporal schema, the spatial reference, and the distribution of the digital geographic data sets. And this standard is applicable when we are cataloging data sets or we are having clearinghouse activities and the full description of data sets for a wide range of geographic application is being undertaken. So it's also applicable to geographic data sets, data series, and individual geographic features and attributes. It may be used for other forms of geographic data, such as map, charts, textual documents, and so forth. So we've discussed the metadata standards, and we said we have the ISO 1915 and the ISO 19139 metadata implementation specification. And we say that all these standards are generated, or rather they are developed at a global level. So they are most likely they are so detailed, they have a lot of elements or a lot of tags that maybe may not be useful in some context, or even they may be missing some tags that are specific to us here or in your context. So we use the ISO 19106 profiling standard to be able to create a subset of these standards, so that we create a subset that is very useful to our context. So the broad standard is a complex, generic, with undefined domains. And the profile is typically narrow focus and often simpler, it is specific, and for a particular domain or application field. Most of the times these international ISO standards need to be profiled to our local context. We illustrate the metadata standard, that's the ISO 19115, and we say that whenever we're dealing with these tags, there are some tags that would be mandatory, that if you're documenting a data set, these tags must be there. And also we have tags that, or elements that are conditional. They are based on a particular condition, and then we have tags that are, or elements that are optional. So we can also extend the traditional tags that are, or the traditional elements that are found in the ISO 1915 standard. So typically we have 22 base elements for these data sets, but then we can be able to add even more tags or even subtract some tags. Now the current challenge with Uganda here is that, well, there's an international standard, but we don't have a profile. And because we don't have a profile, whenever users are collecting data in the field, somehow the big standard will be very complex to use, and somehow most of our data sets are not documented. So here is an example of elements that spatial data should always have. So we have the mandatory elements. Any dataset should have a dataset title. It should have a dataset reference date, when was this data collected, and some small abstract to define the dataset, and then tell us who compiled the metadata, and as well as what is his contact, when was this data compiled, in what language. Then the conditional elements could include the geographic location, the dataset character set. For us in the British system, we use the UTF-8. So in other words, we use our characters from A up to Z. But if you're in the German system, for example, you could find that they're using letters like an umlaut, which is not part of our character set. So for us, we use UTF-8, and also the character set for the metadata, and then also the metadata language if it's not yet coded. Then the optional elements include the dataset responsible party, who is responsible for the dataset, and then also the spatial resolution, that's in case of a raster if you're dealing with raster data, the distribution format, the additional extent, that's basically spatially and in a temporal way. So for example, the data could be for maybe 1990, it could be for 2000, it could be for 2020, and also it could be for Kampala in a spatial way, and then also the spatial representation and the reference system and the lineage information. So like we've already said, these elements we can be able to add more or we can be able to reduce depending on the context. Now, when you have this metadata, so what? So we said that this metadata allows us to be able to advertise the data set so that someone can be able to discover that this data set exists, evaluate the data set, and then be able to use it or reuse it. So for us to be able to do that, we need cataloging services which enable us to publish and search structured information or metadata about geographic resources. These catalog services also enable a requester to dynamically discover and communicate with a suitable resource provider. So below is an interaction diagram of how a user typically interacts with these catalog services. So the user basically finds a website or a web browser, and then he posts a query, and this query is sent the catalog gateway, which has a directory of servers, and then you can be able to search a catalog server, and then you'll search for metadata entities, and then this metadata basically has reference to spatial data. In our tutorials in the Mwele, we shall be able to explore how to access these geoportals or catalog services, and then how to be able to access this metadata portal. So there are different standards. Remember, at one point in time we said that we have catalog service standards. So there are different standards that are used to encode or that are used to specify these catalogs. So we have, for example, the catalog service standard for the web, which specifies interfaces, bindings, and a framework for defining application profiles. Required publish and access digital catalogs of metadata for geospatial data. And also catalogs for metadata for services and related information. We have another standard called the EBXML registry service, which enables us to share information between interested parties for purposes of enabling business process integration between parties based on the EBXML specifications. We have the ISO 23950, which is the search and retrieve protocol, and then we have the UDDI, which is the Universal Description Discovery and Integration Standard. So for you just to know, we have several standards for the catalog. So we don't just build catalogs just like that. This brings me to a particular scenario that I've seen. So one time I saw IT specialists who are told to develop a catalog service, a geoportal for sharing geospatial information for different MDAs. And for them, because they thought this was a portal, they developed their own and they never considered these standards. And at the end, this portal couldn't be used because it was lacking a lot of things that were familiar to geospatial experts. So it is very, very important for you to use these standards when you're creating your geoportals or catalog services. And maybe you can do some kind of specialization or some kind of specialization to your particular context generally. So what do these catalog services do for us, or what do we use them for? For us as users, when we get to the interface, we can be able to search for different data sets. We can search by the query title or by the abstract or the keyword. Remember, these were components of the elements of the metadata that we defined or that we were trying to define in the previous sub-lecture or sub-lesson. We can as well also apply spatial and temporal filters to be able to extract geospatial data sets. So below here, you can see the search. I put in my keyword. For example, I want soil data. And then here it will bring me all the resources that are available for soil. And then if I click one of them, then I can be able to get an advertisement telling me the data that is available, or the data that the user, rather the producer has. It was generated in this year. It is available under these constraints. This is the lineage information and so many other things. But then the second approach to that is to query using the map functionality. So I can be able to put in a spatial filter, the years, and then after I can be able to specify the area, and then it will tell me, to bring me all that information that exists. Now, like we said, the metadata standard is so big. You cannot just get this whole metadata standard and use it to describe data sets. So typically, we create profiles, and here we get the XML document, the schema. Remember that metadata is encoded using XML, as you can see here. So our role is to make sure that we get the schema, and then we can be able to define the tags that we need. So we define the tags here that we need, and then be able to extract the part of the schema that is that's important for us, and then we get it into the database, and all this geoportal database. So it's this profile that we find there and try to search, and then it will tell us this is the data that's available, and you can access it from ABCD. Now, searching this geoportal can also be challenging, because sometimes you can actually you can try to search information, but you seem not to get what you want. And one of the ways how we deal with it is to use the concept of ontology-based searches. So an ontology, it's a very big word, but for us in computer science, we use it to describe some shared conceptualization that has been formalized in a computer. And in this case, we use this to basically be able to search the geoportal. So the current challenge that we have is that, yes, we have standards, we have specifications to ensure technical interoperability, but the challenge is that the terminologies that are used, or the cognitive interoperability problems that arise, usually prevent full discovery of information from these geoportals. So I just imagine you are searching for data about banks, and somehow you're receiving blood banks, but you're interested in a money bank. Or you're searching about data to do with blood banks, you're getting river banks. So that's not what you want. You want to be able to get information at the right time, in the rightful presentation format. So the ontologies basically can be used to conceptualize these terminologies, or cognitive conceptualizations, in such a way that all of us can be able to understand the data. And that would basically enhance geographic information discovery in a catalog service. A geoportal is a one-stop gateway for us to be able to access geo information, be able to use it, and it's just typically a website. And currently, as huge SDIs are being built, geoportals are one of those key components of an NSDI. And we know that people who actually use this geoportal are heterogeneous users. So you could find people from disciplines like agriculture, from geomatics, from environment, and so many other disciplines trying to use this geoportal. And when they meet the information there, they have different perspectives upon the same reality. And that means that if you're going to search using the query abstract or keywords, or even applying the spatial temporal filters, you're going to have keywords that are restricted by ambiguities of natural languages. You're going to have communities that have various perspectives on the same domain. And then also, you'll have different terminologies. So users should be able to discover all the relevant information from the portal, but sometimes it's not very easy to discover that information because of problems of low recall. Like we already said, you're thinking about a bank, and then you are getting nothing. You search the geoportal and you get nothing. Or you're thinking about a bank again, and then you get a lot of banks, and none of those is what you're interested in. So you have maybe a lot of river banks, a lot of blood banks, but you're interested in money banks. So we need to use the concept of ontologies to be able to harmonize that. So whenever we have semantic heterogeneity in data, then that's when we have those ontology issues. Rather, we have those issues to do with semantics. And one of the challenges that we could have would be naming heterogeneity. So if you have names that have been, for example, banks have been named differently, then it's very possible that once you search, you get nothing from the geoportal. But then, if you have cognitive heterogeneity, we all know it's a bank, but somehow we interpret it, we see it differently. Or we see a footpath, and when we look at that footpath, some of us see a big road, others see a footpath, others see nothing. Then in that case, we have low precision. So you have a lot of information, but none of that information is very meaningful. So to be able to solve that, we said we use ontologies, and in the world of ontologies, we have what we call top-level ontologies. These basically define the entire universe of discourse. They are like foundational ontologies. For example, Dulwich is one of them, and maybe the BA4, and so many, the basic formal ontology, and so many other ontologies. And then we also have ontologies for specific domains. For example, suite is an ontology in the geospatial domain. And then we have ontologies that can be for a particular task. So it describes a particular activity. And then we can also have ontologies for a particular application. So on the right here, you see how ontologies are built. So we have a software called Protege. And in Protege, we can be able to define or build these ontologies. And at the end, it is like a schema in a database. So instead of having just columns in a database, for us, we have them as different tags that are related to each other in an ontology. So, like I already said, we use Protege to be able to encode these semantics. In the scope of this course, this is where we stop. But in the geospatial domain, we can actually go further and be able to encode these geospatial data sets using this Protege, and then we can be able to solve semantic issues. Remember, this is a technique of achieving interoperability. If you checked our map that we had at the beginning, we said this was one of the techniques of achieving interoperability. So in summary, GIS standards are recommended practices that facilitate developing, sharing, and using GIS data, GIS software, and GIS services. The objective is to be able, or the objective is to enable an efficient and consistent approach for different information systems to be able to discover, manage, communicate and exchange, and apply geospatial information for a multitude of users. and also improve understanding and decision making. So the whole issue here is just about consistency on how basically we can be able to encode and share this geoinformation. And we have also talked about the different typologies of standards that are found in the geospatial world. We said we have standards that can be defined by nature, and also standards that can be defined by their how legal they are. And then we went on to be able to look at the typical standards that we use in the geospatial domain, and we said we have metadata standards, we have spatial data content standards, and we have spatial data service standards, harmonized geospatial content standards, and catalog standards, or maybe standards for the network services. But then we also said that in our context here in Uganda, we don't have standards that have already been defined. There are standards that are already existing in the ecosystem, but these standards are not consensus based. So everybody seems to be using his standard. There are standards that could be used. Some of them could be at a global level, but we need to contextualize them to Uganda. So one of the challenges for the NSTI is to develop profile metadata standards, to develop spatial data content standards. Currently what's happening, every ministry is developing its own content standards. And now when we come to share information, sometimes may not be useful. The spatial data service standards, those ones are generic. We can always use the ones that are already existing. Maybe we don't need to profile them. And we have also these harmonized geospatial content standards. Maybe we don't need to profile them. But for the spatial data content standards, we need them, and we don't have any of those consensus-based standards. Thank you very much for listening to me. Let's wait to get onto encodings in our next lecture.